Hello, in this video I'm going to talk about the truth table that defines the biconditional. So you should watch the truth table for the conditional video before you watch this. So I'm first going to actually just give you the truth table for the biconditional and tell you what it says, and then I'm going to explain why we give it that truth table. So here goes. When both sides of the biconditional are true, then for any of the sentences, then the biconditional is true. If the left side is true and the right side is false, the biconditional is false. If the left side is false and the right side is true, then the biconditional is false. If both sides are false, then the biconditional is true. So a simple way of saying what the biconditional means is this. It says that both sides agree. It says that they have the same truth value. If we look on the top row and the bottom row, it's true. And what do we see? Same truth values, either both true or both false. They don't have to be true, they just have to be the same. And if they're different, if it's true false or false true, on the other hand, then the biconditional comes out false. So what does the biconditional say? It says the two sentences have the same truth value. It says that they agree. And that's, in the end, all you need to know. But I want to explain why that's the truth table for the biconditional. So why is this correct? Well, so what does the biconditional really mean? What it says is, so we have the biconditional box if and only if circle, and that says if box then circle, and also if circle then box. So the biconditional is a conjunction of the two conditionals. So let's think about how that would then work in terms of the truth values of the pieces. So let's suppose that box and circle are both true. Well, that would mean that if box then circle is true, and also if circle then box is true. And that would mean that the biconditional is true, because the biconditional really is just the conjunction of them. They're both true, so the biconditional is true. Now suppose that box and circle are both false. Well, if we go and look at the truth tables for define the conditional, that would tell us that the two conditionals, if box and circle, and if circle and box, are both true. Remember, on the last row of the conditional truth table, the conditional is true, and that's where we would be if both box and circle are false. Okay, well, then, but since both of the conditionals are true, then the biconditional is true. So what we see here is that if whether box and circle are both true or box and circle are both false, in either of those situations, both of the conditionals are true, and so the biconditional is true. And so that's why the biconditional is true on the top and bottom rows of the table when box and circle are true, or when box and circle are false, i.e. whenever box and circle agree. Okay, well, what if box is true and circle is false? Well, then if box and circle is false, because we have a counterexample to that conditional, we have true antecedent, false consequent. Well, that means that if one of the conditionals is false, then the biconditional is false. What about the other way? Box is false and circle is true. Well, then the conditional if circle then box is false, because it has a true antecedent and a false consequent. And so again, the biconditional is true because one of the two conditionals, the biconditional is false because one of the two conditionals is false. And so that tells us why the biconditional has the truth table that it does. When both box and circle are true, then both of the conditionals are true, and so the conjunction of the conditionals is true, and so the biconditional is true. If box is true but circle is false, then if box and circle is false, and it turns out that circle then box is false, but it doesn't matter because box and circle is false, and so the conjunction of the two conditionals is false, and so the biconditional is false. What about if box is false and circle is true? Well, then if box and circle is true, if you look at the truth table, that's what you'll see. It says, look at the third row of the conditional truth table, but if circle then box is false because its antecedent is true but its consequent is false. So again, one of the two conditionals in the conjunction is true, is false, and so the biconditional is false. Okay, what about if box and circle are false? Then both of the conditionals are true, which is kind of weird, but that's the way the conditional works. And so the conjunction of the conditionals is true, and so the biconditional is also true. And so that's why the biconditional has a truth table that it does, why it turns out that if box and circle have the same truth value, the biconditional is true, and if box and circle have different truth values, then the biconditional is false. So what do we want to remember about the biconditional? It's true if the two components agree. It's false if the components disagree. This is easier to remember than the truth table for the conditional, but it's not necessarily completely easy to remember. In particular, it can be easy to forget that if they're both false, then the whole thing is true. And so again, I would recommend that you use the sheet with the definitions, which now has the definitions for all of our symbols. So you now know everything you need to know to do a truth table for any of our sentences. So good luck with your truth tables. If you have any questions, please let me know.